The number one way that most of you are going to improve your coding skills is by refactoring your own code. If you have the advantage of working on a team where you get daily code review, that's better, but that's not the reality for most of you. Refactoring is the next best thing. It's going to jumpstart your problem-solving skills in ways that step-by-step tutorials can't. So why do we refactor? Just like anything else I talk about on this channel, most often we refactor to facilitate change. You or your players or your publisher want something different, but the way that the code is structured doesn't accommodate that. So today we're going to walk through some tried and true methods of refactoring code. Let's go. We're going to use last week's code because there was a lot of optimization and feature suggestions in the comments and on Discord, and I'm going to use those as an opportunity to refactor my own code as an example. Now, it's not strictly necessary, but I'll put a link on the screen if you want to watch that first. This should give a few insights into how to use these methods and what I'm thinking about when I'm applying them. Okay, so very first rule of refactoring, only change one thing at a time. Second rule of refactoring, commit after every small refactor. Third rule is to constantly run your unit tests as you refactor. But let's be real, most of you don't write any tests at all. So let's work under that assumption, though I may mention it once or twice. So let's get into this first method here, Strangler Fig. The Strangler Fig pattern is a methodical and gradual process of refactoring code by replacing parts of the old system with the new system, while ensuring the whole system continues to function effectively throughout the process. The name comes from the Australian Strangler Fig tree that gradually envelops and replaces its host tree. In the context of programming, the idea is to implement new functionality alongside the existing functionality and gradually switch over to the usage of the new implementation while you ensure that there's no disruption in the overall system. Once the new system is fully operational and all the old references are removed, the old system has effectively been strangled. So this first refactoring I want to do is to migrate from using a linked list to just a regular list because it's not only more efficient, but it's also going to be less verbose. The idea is to implement new functionality alongside the existing functionality and to gradually switch over to the new implementation while we make sure that nothing breaks. Now, it's true that this is a little bit of a trivial change, but that makes it perfect for demonstrating the technique. Let's start by creating a new field here for our new list. We'll keep the name for the original one modifiers, and we'll call this new one list modifiers. So first, let's work on this add modifier method. I want to break up the subscription to onDispose into individual parts so that it's easier to work with. So let's break up this statement lambda into two individual lambdas. With the remove call on the first line, I can remove it from the second part, and then I can also turn this into an expression lambda just so it's a little bit shorter and easier to read. So now we're free to add this modifier to our new list, which we called list modifiers, and we can also, on dispose, we can remove it from that list as well. So this is looking good. We're adding the modifier to both of the lists, and we're removing it from both of the lists. Let's move on to the update method. So our update method is actually doing two things. It's updating all of our modifiers with delta time, and it's also taking any that are marked for removal and calling their dispose method. Now, I don't want to do these operations inside of these loops anymore because we're actually iterating over two lists now. So instead, let's make some hash sets here. So anything that's going to need to be updated can go into one hash set. Anything that's going to be removed can go into the other hash set. Now we can comment out this update method call and instead replace it with just adding it to the first hash set. We can do the same with the call to dispose. Instead, we'll just add that to the to remove hash set. Now, if we come down here a little bit, we can just have two more loops here to perform these operations. Now, we still haven't done anything with our new list here. We don't even have to iterate over the new list. We can just use the hash set's union with method that will add everything from our new list into the to update. And we can do something very similar for the to remove, except we'll just use a little bit of a link here to say we only want to add the ones where the modifier was marked for removal. Now these two lists are the same at the moment, but we're going to be removing one right away here. So now that we've got both lists working in tandem, the best thing to do is either run your tests if you have any, or go and compile the game and make sure that it's running and doing what you think. So I'll just press play here. I just want to have a sense that everything's working as I expect. I have this debuff here that takes my attack down to 0. Over here on the far side, I've got a buff on defense for plus 14. And I've got a couple small buffs on attack, a double on attack. I'll let one wear off here or two. And then I got another one that doubles. So though that's looking good. Obviously unit tests are better than this, but if you're confident, you can continue. So now we're almost done with the refactor and we can start cutting things out. So the first thing is in this update method, we don't need to update our linked list anymore. Let's just select that whole bit and chop it right out of here. Now, we don't really need these temporary hash sets anymore because we're only dealing with one list. So let's first of all move list modifiers from here where we're doing the union with. That can just become what we iterate over in the loop. Likewise, we can do the same thing with the other call, except here, because we're disposing of things in the list that we're iterating over, we should add a to list here so that we have an actual copy that we're iterating over. Okay, let's start cutting out a little bit more. We don't need these union withs anymore. We're not using them. And now we can see the original ones are grayed out. They're not being referenced by anything. We'll cut those too. So now our update method has become extremely small. We've just got a little bit more to do. Everywhere we were using the link list up in here, we can just cut it out. So we'll cut it out of the onDispose. We'll cut it out here where we're adding to the linked list. And now you can see our original linked list is grayed out. It's not being referenced anymore. We can cut it. So now we're down to some pretty concise code, definitely less verbose, and it's definitely going to be more performant. But there is one more thing we should consider, and that is, do we need this event handler anymore? When we invoke on the queries, it's not really any different than running a for loop over every single stat modifier. So I could just do this. Now I can make this entire class even leaner by cutting out the event handler. And then I can get rid of this comment. I can get rid of any of the references to the queries and just clean up some empty space and we're good. Okay, so we've made a fairly significant change now. It's a good idea to go and test everything, at least run a smoke test so you make sure there's no fires. And if you're happy and you want to continue, make sure that you commit all your work. This time, just to make it fast, I'm just going to go right to one end and just run through all of them and just make sure everything's stacking up the way I expect, which it is. And so that looks good. Let's let everything wear off quickly and then come back out of here and we'll make that commit. Okay, with that out of the way, I'll do a very quick little commit here for our first refactor and then we can move on to the next part. Introducing seams is the process of creating a new interface inside an existing system that will allow us to isolate behavior and decouple dependencies. By defining an interface, the existing code can interact through this new seam instead of a concrete implementation. This is one of the key topics covered in what I call the Bible of refactoring, which is this book here, Working Effectively with Legacy Code. Legacy code isn't code from the 80s, it just means code that already exists, maybe even the code you wrote this morning. The first thing I want to do during this refactor is actually extend the scope of the operator type enum and make it accessible to my entire stats system. The reason is, if we look down at the apply pickup effect method, what's really going on with this switch statement? If you look at it closely, doesn't the behavior resemble a factory? Of course it does. And we're going to want to make stat modifiers, not just from a pickup class, but maybe from the inventory or other systems. I certainly don't want to be repeating this code every single place I want to create a stat modifier. First, I'm just going to comment out exactly where I want to use this seam. Now, the seam is going to be an abstraction. We're going to make an interface for it because I could put any kind of stat modifier factory I want in here, including mocks for tests. It's a good idea to write out what you think the arguments are going to be to this particular method because it's helpful when defining the interface for one thing, but don't feel like you're locked into this. Just make your best guess at what information do I need to actually create a stat modifier. Then we can come up to the top here and define the actual interface we want to use. From here, creating our basic factory is simple. In fact, Copilot can fill it out. It's going to be the exact same logic that we had in the switch statement below. At this point, I would grab the factory and the interface and just move them into their own file because otherwise this file is going to get cluttered up. And the factory doesn't belong with the pickups anyway. That's the reason we're moving it out. So once we've got these things over here, let's come back to the stat modifier pickup. And let's just do a little bit of tidy up here. We don't need this switch statement anymore. Let's get rid of it, uncomment out our placeholder, and that's it. We'll just clean up some blank lines. Just one more thing left. We haven't actually assigned a factory into our field here. So the most naive implementation would be to say, I want a new stat modifier factory, but now you've coupled all of the pickups to the factory. The better way to do this is to use inversion of control in some form. You're either going to use some dependency injection or you could use a service locator. So just as an example here, I've got a bootstrapper class here that actually isn't doing anything yet. As part of my startup activities, I can register a new stat modifier factory with the service locator. Then anything in my game that needs to create stat modifiers can just call the service locator and get a reference to this. So back over here in the pickup class, we just add a start method where we ask the service locator to actually get an instance, whichever one is registered for that interface. And then we're good to go. But you know what? We could actually make this even better, because is there really a point to storing it in a field here in this class? Not really. It's already instanced in the service locator. Why don't we just call it directly? So if I do a little refactoring here, I can inline field. Now we can just get a reference directly to our factory and just call its create method right from here. And I don't need the start method. So now by introducing this seam of the interface here, we no longer are tightly coupled to that specific implementation of creating stat modifiers. We can just call the factory and it'll do all the work for us. Now, that's as far as I want to go before doing any testing and a commit. Now, again, we haven't really fundamentally changed the way this thing works. Everything should just be stacking up in the order that I picked them up. And, so far it looks correct. As long as they're coming on and off in the right order. Yeah, okay, this looks good. Let's commit. If you've never seen this before on the command line, if you use double ampersand between your git commands, you can just chain them into one right after the other. So here I'm just adding all the modified files and then checking in with a specific one-line message. There we go. All right, let's move on. If we take a quick look here at the constructor of our basic stat modifier, we're passing in an operation that is a delegate. This is okay for a basic implementation, but it also tightly couples you to this structure of this func. This is another excellent place to introduce a seam. So I'm going to open a new file here and we're going to use the strategy programming pattern. Instead of defining our operation as a delegate, we're going to define it as a strategy. Now, this strategy only has one purpose, and that is to perform an operation. So we'll call that calculate. So far, we've only used two operations, addition and multiplication, but this will give you the freedom to implement any kind of calculation that you want. We need to define the amount of the value that we're actually using in this modification, because we're adding one value to another, and we'll pass that in the constructor. Then we've got a calculate method that just adds one value to the other. Then I'll just do a little bit of cleanup here because this could be a little bit shorter, and the value, of course, can be read only. And then let's also, actually, you know what? I'll let Copilot fill this part out because, it's basically the same thing except we're doing a multiplication. So from here, you can add many more operations. You might want percentages. You might have some complex operations you want to perform. So let's leave it at the two operations for now, and let's come back to our stat modifier. Now, if we take a close look at this basic stat modifier, what was really going on here? The basic stat modifier is essentially a wrapper around that delegate. In fact, the only thing that our base class doesn't have that this one has is a reference to the stat type. Why don't we just get a copy of that down in our stat modifier base class? We can pass it in through the constructor and set it. And now here is where we can also introduce our seam. We can pass that in through constructor injection. Let's make a field for that up top, and then we can assign it as well in the constructor. Just a few more changes to make. First of all, we've got to do something with our handle method. We're actually going to need to call that calculate method on the strategy. So let Copilot fill that one out. And then if we come up a little bit up here, now the basic stat modifier at this point serves absolutely no purpose. Let's just cut the whole thing out. Then we need to change the base class. It's not going to be an abstract class anymore. We're actually going to start using it and instantiating it. So let's remove the abstract keyword and let's make the constructor public. Now you might be thinking, cutting that one class out that was being referenced, isn't that dangerous? In a large unstructured code base, I would say yes. But we've moved all the creation logic into a factory. And that's what makes factories such great seams in refactoring. There's really only one place to change, and I can let Copilot fill it out. Check this out. All we have to do is select a new strategy based on the operator type that was defined in the editor, and then we can instantiate a new stat modifier. I'm just going to name some of these variables a little bit better. We can call this just strategy. And up in the signature for our create method, we're actually saying operator type and then type. So I'll just rename this to stat type. There we go. Okay, let's do a quick little run through again, just a little quick sanity check, just make sure that everything looks like it's working. And of course it compiles. Yeah, okay. Everything's looking good. Just let them fall off here and then we can go make another commit. So we can say that we did refactor number 3, which was to add an operation strategy. Perfect. Okay. All right, now the next suggestion was to consistently apply the modifiers in the same order all the time. For maximum flexibility, we can introduce another interface, and essentially this is going to be another strategy. We can call it istat modifier application order, and it only needs one method, which we will call apply. It's going to accept our stat modifiers and the base value and apply everything in the correct order. So let's make a concrete version of this, and we'll just call it the normal stat modifier order. So inside this method, we're going to have to be able to sort these by the kind of operation that's being performed in the modifier. So our add modifiers should generally be done before the multiply modifiers. But to do that, we're going to have to go over to the stat modifier and actually expose the operation strategy that each one is using. So let's make that public, and then we can come back and we can use some link to just say all the add modifiers are the ones where the modifier strategy is an add operation. With that hint, Copilot should be able to figure out how to do the multiply modifiers. There we go. Writer is showing a little yellow warning about enumeration. We can first enumerate everything to a list, and then we'll do a little cleanup on this in a minute. Just for now, let's give that a slightly better name, maybe all modifiers. And then we can just come down below and we can apply all the add modifiers, and then we'll do the same thing with the multiply modifiers. Now, this whole thing could be a little less verbose if we just inlined these variables for the add modifiers and the multiply modifiers. So if I just come up here and hit Control R, I can inline this variable. Same thing down here with the multiply. Control R, inline variable, and there we go. So let's move all of this sequencing out of here into its own file. I'll call that stat modifier application order. And potentially you might want to have other orders for some sort of gameplay reasons. I'm just going to quickly do a little bit of cleanup. I'm just going to remove these two list method calls. Also, if we come back over to the stat modifier, I had made a few things public over here. The stat type and the strategy, we should really have those as properties. On top of that, the marked for removal property really shouldn't have a public setter, but we won't do that as part of this refactoring. I'm just going to put a note here for myself. Usually when I see something like this, I want to do it in a different refactoring. I'll just put a note like a to-do or fix me is more common. Then if I'm working on a project, I can quickly search for all my fix me's and I won't forget about it. Now, before we do the next part, I want to talk about another refactoring technique called wrap method. The wrap method involves creating a new method that encapsulates an existing method, and it allows us to add behavior before, after, or around the original call. This technique makes it easier to extend and change functionality without modifying the original code and not breaking anything. This is just another one of the many techniques featured in the book that I mentioned earlier. So the first part of wrap method is to duplicate the signature of the method that we're going to wrap. So I'm just going to copy it. Now the signatures match, so I've got to rename the old one. And then what we're going to do is toggle between this old behavior and the new behavior we're going to try to test out. The easiest thing to do is create a little Boolean flag. We can call it use old query. And that way, let's first define a signature for what we are going to test. And that was to apply the modifiers in a specific sequence. So we'll call that perform sorted query. This is going to let us test the new behavior or the old behavior in a very non-destructive way. So in the perform sorted query, first let's get all the modifiers that apply to this specific stat type. Then we're going to need an instance of our strategy that's going to apply them in a sequence. Now, creating an instance right here is a tight coupling. That might be okay, but it might be more useful to actually inject this as well. So I'll just put a note there. Now we can use that order to actually apply the modifiers in that order, and then we'll set the value to that. Now these two methods, they don't have to be public. Let's remove that. But let's also move this normal stat modifier order creation out of here. It's really a class member. We don't want to create one every time we call the method. So now that we have the wrap method in place, it's time to test. Okay, so this time we need a little bit more of a comprehensive test because we're doing things in sequence. So let's try going from this side over here. We'll grab a +10, and then a ×2. So that gives us 60 attack. Now let's do it in the opposite order and just make sure that that works the way we think. We should still get 60. Perfect. Okay. So now that we're happy with this, we can actually get rid of the wrap. And the first thing I would do is get rid of the call to the perform old query and just clean this up a little bit and get rid of that Boolean. We don't need that either. And now if we look at this, these two methods have exactly the same signature, right? So instead of having perform query called perform sorted query, let's just select all of the stuff in between those two things and cut it out. Now at this point, you should be running your tests or going and testing your game again by compiling it or both, and then of course committing your work. But to keep this video short, I'm going to not record that part and just jump right into the next part here. Okay, just one more small addition I'd like to make before we wrap this up, and that is let's cache some stuff. Now there's two ways you could go about doing this. The first way is that you could cache this entire list of applicable modifiers, and that way we don't have to do that sort every time we're coming in here. Let's just comment that whole line out, and then I bet you Copilot will be able to figure out exactly what it is that I want. Yes, exactly. If there's no key for this particular stat type, then we are going to sort that list out and put all the ones for that stat type into the cache. And then we can come down here to where we're passing that in. Instead of passing in the list, we just grab whatever's in the cache. Now we're also going to have to invalidate that cache whenever our list of modifiers changes, right? So why don't we add another method here? We can just call it invalidate cache, and that will remove that particular entry from the dictionary. Then down in the add modifier method, whenever we're disposing of a modifier, let's invalidate the cache for that type. And whenever we're adding one to the list, let's also invalidate that cache. Okay, a little bit of cleanup. The dictionary can be read-only. We can get rid of this line that we commented out. Let's have one more run through here, just make sure that our cache is working the way we expected. Now, the other way I was thinking for caching is that you could actually cache the sequence of application, because that has two sorts in it as well. So that would be even more efficient, but a little bit more work. So I'll leave that to you guys to implement on your own. Maybe I'll put a commit into the repository as well later on. Now, I made a premature commit before I hit the record button. So now I'm actually going to amend that commit because it doesn't include the invalidated cache stuff. Well, I hope that short video gives you some insights in how I go about refactoring. Refactoring is actually about 50% of the code I write at work. Now, refactoring doesn't mean that the old code was necessarily bad. Most of the time, it just means that it needs to be improved to facilitate a change. The more that you refactor your own code to accommodate features and whatnot that you want to implement, the more your ability to think in systems and see where seams should be and how you can use patterns. These things are all going to start to come together. The light is going to go on more and more frequently. It's going to get easier and easier. And of course, it's always easier to get insights from your own code. I strongly recommend reading that book that I mentioned earlier, and I'm sure we'll be talking about it on Discord if you want to join us there. I'm going to preserve all the commits I made today in the repository, so if you want to go and look at them again step by step, you can. I'll put a few boxes up on the screen here about related topics, and maybe I'll see you there.